To find if the graph is continuous at f of g of x when x equals 0, we first find g of x at x equals 0. This is positive 1 and 2. Now we plug in 1 and 2 for the f of x graph. At the points x equals 1 and 2, both of these points are continuous. This also works with all three rules of continuity, that f of c exists, that the limit as x approaches c exists, and the limit of f of c is equal to the true value of f of x. Therefore, f of g of x is continuous at x equals 0. For g of f of x, we first find the value of f of x at x equals 0. This is 0. Now we find the value of g of x at 0. This is 1 and 2. Now if we look at the rules of continuity, this doesn't follow the rule that the value of the limit as x approaches from the left is equal to the value of the limit as x approaches from the right, because the value of the limit as x approaches from the left is equal to 1, and the value of the limit as x approaches from the right is equal to 2. Now to find the limit of f of g of x as x approaches infinity, we see that the limit of g of x as x approaches infinity will increase forever. And if we plug in the values of g of x into f of x as x approaches infinity, the limit will remain negative 1 in the f of x equation. Therefore, the limit of f of g of x as x approaches infinity is negative 1. And as the value of x as x approaches 0 approaches from the right in the f of x equation, the value of the limit is negative 1. And the value of the limit as x approaches from the right of g of x is positive 2. Since these two values should be equal to each other to make the graph continuous, we set the two equations equal to each other. Since we already found f of x, g of x as x approaches from the left, and g of x and f of x as x approaches from the right, we can plug these into the equation. Then we solve for k by dividing by negative 2 on both sides, and k ends up being negative 0.5.